Hello there and welcome to video number 187. This video is on the probability scale and is the first one in the probability and statistics section, and it's been a long time since I've done one of these videos, so welcome back to me, I guess. So the keywords I've got for you are probability, fair and biased. Probability is the chance that something's going to happen. Fair is used in relation to experiments that are done in the world of probability, and it means that it's one thing isn't favoured over another. And biased is the exact opposite. It is when something is favoured over something else. So you might get a biased coin if it lands on heads more than it does tails. You know, obviously a lot more than heads than it does tails, etc. Because obviously experiments are experiments, and I'll get into that later on anyway. Right, so the method states that the probability scale ranges from 0 to 1. This is something you're going to need to learn exists. And we can attribute words to the different parts of the scale. The 0 represents impossible. The event isn't going to happen, never going to happen. 0.25 or 25% or a quarter, right? Because they are interchangeable. They can be fractions, percentages as well, but mostly we see it as a decimal. 0.25 represents unlikely. 0.5 represents even. 0.75 likely, and 1 represents certain. It's definitely going to happen. Now, the events can be calculated and be put onto the scale or placed exactly into particular positions, and it doesn't have to be broken up into exactly those things, but it is in these questions that I've got here. Or it could be like a more ambiguous sort of event, and we can place it somewhere along the scale or come up with an idea of how likely something is going to happen if we know where these points lay on that particular scale. So we're going to be asked to use words or the decimal or fractional percentage to explain the chance of an event happening. And in the first question, we're going to choose a word from the scale to describe the following events. So first event is a buffalo will become Prime Minister. How likely is that? Well, a buffalo, some people might argue that a buffalo might do a better job than the Prime Minister. I might not be one of those people. I might be, who knows? But a buffalo can't become Prime Minister because a buffalo is not a human being. A buffalo is an animal, so it is impossible for that to happen. And there will be always, whenever I teach this in class, there's always a student who goes, oh, well, what if the rules change, blah, blah, blah. It's mathematically impossible, okay? It's not going to happen, all right? We have to make a decision somewhere along the line, don't we? A healthy cheetah runs faster than me in part B. A healthy cheetah is going to be very, very fast. It's definitely going to run faster than me, so we'd say certain for that one. Okay, some people might argue that it's not certain. A healthy cheetah, come on, it is definitely going to run faster than me. And in C, it will snow in June. How likely is it going to be to snow in June? This is interesting because currently the weather that we've had this week, it's been really weird. We've had snow and sun at the same time. It's been slightly warm and really cold in the same day. I say slightly warm, the sun's been out and it's warmed a bit of the garden up, but yeah, it's not going to snow in June, is it? It's not very likely to, but it's not impossible. So we're going to say it's unlikely. Okay, and it might not be that it's exactly a quarter of a chance of happening. It's probably more closer to 0, but it's still unlikely. We could say it's very unlikely if we wanted to be more specific, but we've chosen from the words and put them in the right places, I think. Now, in question 2, we've got to place the letter of each event on the scale below. This is where we can actually do some calculation. We can do some very basic maths here in terms of the worlds of probability. Guessing a heads when you flip a fair coin, everybody should know that a normal fair coin has got two sides, heads and tails. One of those is heads out of 2 of the options, heads and tails. So it's half a chance of happening. Half a chance is equal to 0.5, okay? Or it could be 50%. If you're not sure those conversions, watch the fractions to decimals percentages video that I've made in the number section. But 0.5 is what the scale is in here, so that is event A. Event B, getting a blue ball from the bag that contains 2 blue and 6 red, so the total number of balls in the bag is 8, because we add the 2 and the 6, and the blue is 2, so there's 2 blue ones out of the 8. All right, we can simplify that fraction. We can divide both those numbers by 2 to make it 1/4. Okay, and we're a quarter of the way along. 0.25. That would be B. Okay, we can say that that's 0.25. Exactly there on the scale. Now, what's the chance that we're going to roll a number that's between 1 and 6 on a fair dice? Well, a fair dice, everybody again should know, and these are sorts of things they do expect you to know. Should know that a dice has got 6 sides, 6 numbers on it. The number is definitely going to be between 1 and 6. So we say it's certain right up here for event C at the end. Okay, so should be pretty simple to place those on a scale. In question 3, you've got Valerie, and Valerie says the probability of getting a prime number when you roll a fair dice is 0.5. Is she correct? Just move myself over here. Now we need to explain the answer. So the probability of getting a prime number, well, the problem with this question is you might not know what a prime number is. A prime number is a number that has only got 2 factors. 2 is the first prime number. I'm going to write down primes here because we need to know our prime numbers. All right. That's a prime number. It's the only even prime number, the very first prime number. It's only got 2 factors, 1 in itself. 3 is the next one, then 5, then 7, then 11, then 13, and 17, and 19, and 23, and 29. If we can remember these 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then that's great. Okay, we can work out other primes after that by thinking about how many factors it's got. If it's got 2 factors, it is a prime number. But that's what we needed to know for this question. In fact, we didn't need to know all of that. We only needed to know these 3 because 7 is not on a dice. A fair dice does not have the number 7 or anything thereafter that. So there are 3 numbers out of 6 numbers that have this prime nature to them. So 3 out of 6 numbers are prime. So Valerie is correct. 3 out of 6 equals 1 over 2 equals 0.5. Okay, there you go. That's how you answer a question that's slightly more complicated on this particular question. All right, I hope that makes sense to you. I hope you enjoyed this first video back that I've done. I've not been here for a while. Keep liking and subscribing and telling people about the resource, and hopefully with whatever happens next year, hopefully we'll be doing some sort of GCSEs nationwide, and then everybody will start watching these videos and realising actually they're not so bad and they can learn some things from them. Alright, take care and look after one another. Thanks very much. Bye bye.